What kind of event could leave behind a galaxy this perfect? 600 million light-years from Earth, a bright blue ring surrounds an old, golden core. Between them lies a broad, dark gap, so clean that the structure looks designed rather than formed. But Hoag's object is real, and the most important clue is not its symmetry. It is the fact that the center and the ring appear to belong to different chapters of the same galaxy. The core is dominated by older, yellow stars. The outer ring is filled with younger, hotter, blue stars. Between them is a region with far fewer visible stars, although deeper observations suggest that the gap may not be completely empty. So Hoag's object is more than a beautiful shape. It is a record of where stars formed, where they stopped forming, and where gas somehow gathered into an enormous, detached ring. Before we go deeper, subscribe to Endless Astra for more real cosmic stories built on science, not fiction. Hoag's object lies in the constellation Serpens and spans roughly 120,000 light-years from one side of its outer ring to the other. That makes it slightly larger than the Milky Way. This is not a tiny oddity. It is a full-size galaxy arranged around a central body with extraordinary precision. Astronomer Arthur Hoag discovered it in 1950. At first, its identity was uncertain. The object resembled a planetary nebula, but Hoag soon suspected that it was a galaxy. He also considered whether the ring might be produced by gravitational lensing. Later observations showed that the center and ring belonged to the same system. The ring was not a distorted image of something behind the core. It was made of stars. That solved one mystery and created a much larger one. How does a galaxy place young stars in a nearly circular outer ring while leaving an older stellar body isolated at the center? The obvious suspect is a collision. Some ring galaxies form when a smaller galaxy passes almost directly through the disk of a larger one. The impact launches a density wave through the victim galaxy. Gas is compressed as the wave moves outward, and new stars ignite along the expanding ring. The Cartwheel galaxy is the famous example. Its warped structure, spokes, disturbed material, and surrounding companions still carry the visual evidence of violence. Hoag's object does not present such a clear crime scene. There is no obvious intruder beside it. There is no dramatic bridge of stars. There are no bright tidal tales announcing a recent collision. Its core and ring look unusually balanced, and the system is relatively isolated. That does not make an ancient interaction impossible. If another galaxy passed nearby 2 or 3 billion years ago, much of the debris may have dispersed or become too faint to detect. But observations of Hoag's object do not support a recent major accretion event. Its visible structure is too settled, and its gas does not show the unmistakable disorder expected from a fresh impact. So the collision theory remains possible only if the event happened deep in the past. And that leads to a quieter explanation. Perhaps the ring did not begin with a violent impact. Perhaps gas arrived gradually.
Radio observations reveal that Hoag's object contains a vast reservoir of neutral hydrogen. This gas structure extends far beyond the bright optical ring, reaching roughly twice its visible size, and its outer regions are mildly warped. Hydrogen is the raw material for new stars. But gas does not form stars everywhere equally. It must become dense enough to collapse. One proposed scenario suggests that the old central galaxy formed first. Later, cold gas from the intergalactic environment accumulated around it, building a large, low-density disk. Most of that disk remained too diffuse for intense star formation. But the gravitational influence of the central body may have organized denser material into a tightly wound pattern. Where the gas became compressed, young stars formed. From Earth, that pattern appears as a nearly complete blue ring. This idea explains several clues at once. It explains why the core is old. It explains why the outer structure is young. It explains why the system contains so much neutral hydrogen. And it explains why the ring can look orderly without requiring a recent catastrophic collision. But it is still a reconstruction. The gas may have arrived from the intergalactic medium. It may have come from an ancient interaction whose visible evidence has faded. Or both processes may have contributed at different stages. Hoag's object shows astronomers the final arrangement. It does not preserve a simple recording of how that arrangement formed. The blue ring is the most active part of the galaxy. Its color comes from young, massive stars that burn hotter and brighter than older stars. These stars live quickly, so their presence tells astronomers that star formation occurred there relatively recently. The yellow central body tells a different story. Its light is dominated by an older stellar population, more like an elliptical galaxy than the bright central disk of a normal spiral. The apparent gap between them creates the illusion that the ring is floating independently. Yet the gap may contain faint stars and diffuse material that Hubble's famous image does not show clearly. Dark does not always mean empty. Sometimes it means that the matter is too faint, too thin, or too cool to dominate visible light. And Hoag's object becomes stranger when you look through that gap. Near the 1 o'clock position in the Hubble image, another small ring galaxy is visible far in the background. It has no physical connection to Hoag's object. The alignment is accidental, but the result looks like a ring inside a ring, as though the universe placed a distant echo of the same geometry inside the first mystery. That visual coincidence is real. The deeper symmetry is the part astronomers are still trying to explain. Perfect circles are difficult to preserve in galaxies. Gravity from nearby objects can distort them. Internal asymmetries can stretch them. Mergers can leave shells, streams, and tidal debris. Even an orderly disk can develop bars and spiral arms. Hoag's object appears unusually smooth because we see it almost face-on, but viewing angle alone cannot create its detached stellar populations. The ring must still be physically maintained around the old central body. That means its structure can reveal something about the galaxy's gravitational history. The motions of its stars and gas matter as much as the image. If the ring and core share a stable orientation, the system may have had billions of years to settle. If the gas carries subtle warps, they may preserve evidence of how material arrived. If star formation follows a hidden spiral pattern rather than a perfect circle, then the apparent ring may be the visible part of a more complex structure. This is why Hoag's object cannot be explained by appearance alone. A photograph shows the puzzle. Spectroscopy and radio astronomy reveal its history. Astronomers measure how the stars move, how old they are, where hydrogen is distributed, and whether nearby galaxies could have influenced the system. So far, those measurements have ruled out the easiest explanations. Hoag's object is not a gravitational lens. It does not resemble a fresh head-on collision. And a simple transformation from an ordinary barred spiral does not comfortably explain all of its observed properties. The leading possibilities now involve ancient interaction, long-term gas accretion, internal gravitational organization, or some combination of them. That uncertainty is not a failure. It is the honest boundary between an image and a history. Galaxies evolve over billions of years. The structures we observe today may be the final frame of events whose earlier stages have disappeared. A tidal stream can fade. An intruder can move far away. Gas can settle. Stars can age. Violence can leave behind symmetry. That may be the real lesson of Hoag's object. The universe does not need to begin calmly to end with order. A galaxy may suffer an interaction, absorb new material, reorganize its gas, and eventually become so balanced that the cause of its transformation is almost erased. Hoag's object looks simple because time may have removed the evidence that made it complicated. And yet one clue remains illuminated around the entire galaxy. The ring is still forming stars. Something placed gas there. Something kept that gas away from the center. Something compressed parts of it strongly enough to create young, blue stars. And whatever happened produced a structure about 120,000 light-years wide that has survived long enough to appear almost geometrically perfect. The unanswered question is no longer whether Hoag's object is real. It is which part of its history we are still missing. Was the ring born from an ancient collision whose scars faded? Did cold intergalactic gas slowly settle around an old elliptical core? Did the core's gravity organize that gas into a hidden spiral that only looks like a ring from our viewpoint? Or are these separate pieces of one longer evolution? Future observations can test those possibilities by mapping the hydrogen in greater detail, measuring the ages and motions of stars across the ring, and searching for extremely faint debris around the galaxy. The answer may never be one dramatic event. It may be a sequence. An old central galaxy, a new supply of gas, a gravitational pattern, a ring of young stars. Billions of years of settling. That is what makes Hoag's object more than one of astronomy's most beautiful images. Its appearance is almost perfectly clear. Its history is not. 600 million light-years away, an old golden core sits inside a blue ring of young stars. The dark region between them makes the galaxy look impossible, while the hydrogen surrounding them suggests that the visible ring is only one part of a much larger structure. Hoag's object does not violate physics. It reveals how difficult it can be to reconstruct what physics has already done. Drop a comment. What do you think created the ring? An ancient collision? Gradual gas accretion? Hidden gravitational dynamics? Or a combination of all three?